Hi, I'm Harris Bright of Two Electrical Guys. We're here today to show you how to test receptacles. Behind me I have what's called a test board. Number one, the test receptacle is a GFCI. This receptacle, if you look closely, the slots look like they're closed in. That's because it's a tamper-proof receptacle. Tamper-proof are the newest type of receptacle that all the new installations will probably have. Here I am trying to push the probe in with one, and obviously it's not going to be going in. In order to get a good test, you have to push both in at the same time. That's why it's called tamper-proof. It's to keep children from plugging in keys and other metal objects into a receptacle and getting themselves injured. Now this happens to be a GFCI. You have two slots. One is a large slot, one is a small slot. The small slot is the live wire, and the big slot is the neutral wire. And then we have the third slot right here, which is the ground. Now, if I plug in the hot leg, obviously, it's not going in. I forgot. Got to push both of them in together. There we go. Now, if I go to ground, I tripped that GFCI. That's not good. So what happened was power leaving this live wire went to ground. So there was a difference. So I have to reset this. And now this receptacle is reset. This GFI is operating properly. Let's go to number two. If I plug in number two, it's showing that there's 120 volts power. And again, you have a small slot and a large slot. And if I go to ground, I tripped the GFCI again. So I'm going to reset it. Now, if I go from ground to the yoke, it's showing that I have what's called continuity. This ground and this screw are connected together through the yoke of the receptacle. If I go from the ground to the neutral, I'm showing continuity. And why is that so? Because at the main electric service, the grounds and the neutrals are tied together. So this one is properly wired. If we go to the number three, I'm going to plug it in again, and it's showing that there is power coming to this receptacle. And if I go to ground, nothing. I'm not reading anything. If I go to the screw, I'm not reading anything. Not even, let's go to continuity. Let's see if we have anything. I do have continuity, but I don't have anything going from this neutral to the screw. This receptacle has an open ground, and that's how I was able to determine it. On this receptacle, I went from the ground and the neutral, and I showed that I'm reading continuity, so this is properly grounded. This one here is not properly grounded. I get no continuity between the ground and the, yeah, I'm supposed to get it on that. You got the ground and the screw are on the same yoke. But if I go from the neutral, nothing. I'll now use a tester. If I plug it into this guy, it's showing that one light in the center is on, and that indicates, according to the scale you have here on the side, that it's an open ground. If I go to the second receptacle, it shows that two lights are lit, and it says that it's properly wired. Now don't forget, this tester has 3 prongs: hot leg, neutral, ground. So this tester does the same thing as this tester, except this is very easy to read, but this is really more accurate. But I know most home inspectors don't carry testers like this. You'll have to depend on a tester like this to do all your checking. In addition, you're going to see a button. If I plug this in and push that button, I just tripped the GFCI. And what I did was I put approximately 6 milliamps to ground. I created a problem. In other words, I created a situation where some electrical device was leaking to ground. That creates a problem of all the power that leaves on the live wire does not return on the neutral. It's going to ground. Therefore, it creates a fault, and that fault trips the GFCI. If I go to the third receptacle and plug it in and push the button, nothing happens. Because without a ground, the receptacle is not properly grounded and doesn't have a continuity back to the GFCI to show that there was a fault. There might be a fault on this device. However, this will never indicate it because there's no ground wire going back to the main electrical service.
If the GFI trips off over here, does it shut off that receptacle 2 and 3?
Yes, this GFCI can control up to 8 to 10 receptacles, and they can all be daisy chained, that the last one can shut off all the receptacles. And that's part of the electrical installation that's allowed by the current and even the previous, electrical codes.
Well, on 3, if I push the test button, why won't it trip off?
Well, because there's no ground. If you don't have a ground, you can't show a fault to ground, and therefore you don't have any continuity back to the main electric service.
So if you were testing this, you have no protection at number 3.
That's exactly right.
So if I go to number 2 and we plug in the tester there,
Right.
and we see that it has 2 lights, we push the button,
I just tripped the
the
GFCI.
GFI goes off.
Right.
Now, instead of resetting it, let's go over to number 3, and is number 3 off?
Let's see. Plug in our tester. Yes.
Number 3 is off. So it's GFI protected, but it will not trip off since there's no ground.
Correct. So if I reset this, now you're showing that there's power back on.
Harris, thank you very much. This is your 7-minute class on inspecting GFIs.